Good morning. Welcome to yet another virtual GSE day. This session is session 3AV and is being presented by Bernd, nickname Yossi. And if you have any questions during the session, please put them in the group chat. If there is an appropriate moment to ask it during the session, I will do, else we'll answer them all at the end. Please remember to give feedback at the end of the session. You can do that through the QR code or through your bring your own agenda. And there is a link that I believe will probably be in the presentation on the last couple of pages. So settle back, enjoy. Over to you, Ben.
Thanks, Anna. Good morning, everybody. My name is Bernd Josmeyer. As Anna already said, I'm an IT architect and working in the IBM lab in Germany, Böblingen, which you see over there. Normally, I'm located in that building there. However, what is normally in 2020, I'm at home, and now I'm trying to give you some kind of some presentation about the topic automation talking about automation in different environments, DevOps and hybrid cloud environments. To the background, I'm working for IBM, as said, now for the product IBM Z System Automation. I have a background for almost 20 years now for different automation products, coming also from the distributed world, but now I'm in the mainframe Z System Automation, and but also now being responsible in that vision we have with Z System Automation, which we have like the journey to cloud path, where we add new features and to this product in order to enable it to work with modern cloud platforms. So let me begin. So I prepared agenda, and first of all, let me start with kind of motivation, talk about classical automation environments, give a little bit background, about people, processes, and tools, traditional being used. Next, I will talk about the challenges, what the change to the DevOps environment team, DevOps environments and teams mean, and how we answer to those challenges. And as a third item, I want to talk about the automation hybrid cloud environments. And I want to talk about tools being used nowadays in hybrid cloud for interacting with IT environments, made public cloud, private cloud, or traditional on-premise IT centers. And but first, I start with classical automation environments. So first, let me give a little bit overview about roles you have in your company. And I want to start with the role of a developer. And here you meet Eric. He is an application developer, and he designs, implements, and delivers new applications. Okay, any applications which are required by the company, maybe an insurance company, a banking company, or some kind of production company, and which want to have, for example, a web presence. They want to have applications which advertise their products and make an interaction with their customers. So Eric is in charge of planning, coding, building, testing, and last not least, releasing those kind of applications, which are hosted on an IT center. And for now, let's start with an on-premise IT environment here. Let's assume the application is running on ZOS in this environment of this company. So you learned now who is Eric and what he's doing. Now let me introduce some other people from the same company, Zach and Mike. They work in a different department, but they are system programmers. Their goal is to provide a stable environment and of their IT center, And so they are in charge of deploying new applications, deploying new versions of applications when there are some. Operator monitor them. Operator monitor means they always keep an eye on that everything is running smoothly, everything is giving service as expected. And in a high level, you can say they ensure availability of everything. So that's their job, keep stuff running. So Beck and Mike are using utilities for their job and for operating, monitoring, automation, and ensuring availability. They use, in this example here, tools like IBM NetView or IBM Z System Automation, which help them to monitor both hardware and software and see what's going on, see statistics about response times and so on, and ensure, last not least, ensure availability 24/7 by 365 actually. So it must be, everything must be running and going on, even if Zach and Mike are not at the shop right now. So the software itself help them to, especially for operating and monitoring, by receiving events and by looking on messages written by software to system logs and to other files, and by integrating with them and interacting with them by issuing start-stop commands wherever appropriate. So those applications, the NetView, the system automation, help them help to do software automation, but also hardware automation, which means that the same here, that we also interact and control the hardware on which the software is running. So whenever there is some critical message and like, for example, it's getting too hot for some failure in the hardware components, it will be notified, and Mike can react on it and, for example, replace some faulty component in the server. And but by doing so, they first need to interact with the software and tell the software, okay, that component is not working anymore. So first move to another one, to another system, and then they can replace the system, for example. So all it's done and facilitated with help of the product asset. And here in the case of system automation, there is some configuration needed for system automation to understand the software which is running on the systems. And the configuration is done in a so-called automation policy. An automation policy is a rather static description of what's running where and what software piece is requiring what other software piece. When that other software piece is not there, then the upper layer software should not run anymore because it will create failure and so on. All that is being created in an automation policy. And so far like in the last decades, that was fine and that was enough, because the change of the software stack was not that often being done. So therefore, you could rely on a rather static description of those kind of dependencies on software and on systems. So but that means also in the past that whenever Eric, for example, developed a new application, a new version of an application or a complete new application, Second might have to integrate it into their managed environment. So that new application has to be added to the policy. It's in order to ensure also the automation and availability of that new application. So the new application has to be added to the policy. That means change policy. Change it and review the change and accept the change and roll out the stuff. It's a timely process, a process which takes time. After time, the new application is part of the whole software stack running on the IT environment. So at a new application to the policy in the past was normally things like you see here in that phone call. Here's Zach, the senior system programmer, calling Mike, his colleague, who is an automation administrator. He says, "Hi, Mike, I just received a call from the application department. They requested a new IMS region. Can you please create an automation for it?" Mike responds, "Hi, Zach, sure, no problem. Takes me just 5 minutes. I'll use the same settings that I used for the region I created the other day." "Yeah, that sounds good. Thank you." So 5 minutes later, after copying from existing APL entries, are those resource entries in the automation policy, and modifying some fields, Mike says to himself, "Done now. Now I must wait for the next change window coming on next Saturday." On next Saturday, which is actually a few days later, okay, let's build now a new configuration from that policy and refresh it on the target system. So after like a few days, only after a few days later, Mike can call now Zach and say, "Hey, Zach, automation is done for IMS region." And yeah, Zach is also happy again because the new application is now being ensured for availability on that system as any other application does in his shop. However, it took them actually a few days to roll out a new application. Now things are changing. Now we have 2020, or actually it changed already a couple of time ago. We have the challenges in so-called DevOps environment. First off, let me talk about what means DevOps. So I introduced you, Eric, Zach, and Mike, and I introduced them with their responsibility. Eric is a developer. Eric is there for getting requirements for new applications. He plans for those changes. He designed them. He codes them, builds, tests them intensively. And after he is done, he releases and goes home, actually, because then his work is done. But now is the time where the operation team starts working actually on that new application. So they need to deploy it, they operate and monitor it, and yeah, more or less ensure availability. So this is the normal traditional way of parting into departments in any shop, in IT shop, and giving responsibility to different job roles. The DevOps world, that changes. In the DevOps worlds, actually what you say is you bring those teams together. You bring them together to deliver features, deliver new applications, but that means deliver from implementing, testing, and deploying it, but also into operating it. So Eric, Zach, and Mike are now not in separate departments anymore, but now being asked to work together as a team to ensure new functions come out for production and make money for their company. So that's what all DevOps is about: bring teams together. So developer and operators are now together responsible to deliver new functions and keep everything running. So again, there was a conflict before. So the conflict is here visualized by, you have on the one side Eric, who is measured by the number of changes, features, and defect fixes, and he really wants to do many changes. He wants to do pushes of new versions of the application, even to production, that new features come out or defects are being fixed and stuff like that. However, you have Mike and Zach, their goal was to stabilize that environment. And for them, changing environment was not really a good idea, because change means potentially problems, and they want to avoid problems because they want to have a stable. So that was a conflict. In a DevOps environment, you are shifting left those kind of conflicting operational concerns, and you bring development and production together in a team. And as one team, everybody, they are responsible for applications. And that means not only you're done by developing new features, by just coding it and releasing it and then say bye-bye, get it running by yourself, dear production team. No, now everybody has to see the complete living cycle of an application. And Eric, Zach, and Mike are all together in the boat to get the stuff developed, tested, and running. So in a DevOps team, you have typical characteristics. So you develop and test against production-like systems and not on development systems, which very often tend to be different to the production systems. You deploy, that means you bring the software out to production with repeatable, reliable processes. So you need automation products that help you doing the stuff. There is actually no good thing to say, okay, I'm done. I put my files on disk and give you like a short notice, take that files and bring it to production. That is, no, we want to have a repeatable process. And this you can more or less only achieve by tools, by automation products, and I will talk about that later. You need monitor and validate operational quality. So operational quality is much more than just like looking, is the CPU consumption, how good is the CPU consumption? Are we running out of CPU, for example? What is the disk space doing? What is network bandwidth telling us, and so on? No, people, also production people, need to know more, like the components of the functions being developed, and so and also see when there is a problem with one piece of that application being developed, whom to ask in the team of development, and whom to ask, if it's Eric or his fellows and colleagues in the same department. And they all talk together to get the stuff running. So production understand the product much more, being the application much more, but also development is being asked to understand production needs. So they need to understand what it means to work with monitoring data, to see on CPU consumption, on some bandwidth, what customers have with that product, and so on. So they need to take those numbers into account to develop a new version of an application to make it ever more enjoyable for customers to use. And yeah, last not least, bring more money to the as customers bring more money to the company they work for. So as I already said before, DevOps is not only a change in the architecture of teams, but it also means that you need to have automation tools that provide those kind of dynamic DevOps capabilities. We cannot wait days anymore that an application that has been developed in a new version is being completely automated in a production environment. That's not possible anymore. So what did we do in system automation here to cope with those challenges is we introduced in System Automation 4.2, I think 1.5 years ago, some new concept we call the dynamic resource concept. So a dynamic resource is something that an automation administrator can create a build plan, or we call it a template in that automation policy to be used later when an application comes that fits into that template to be automated. So on request, so whenever an application, a new version of an application comes out, a dynamic resource is being created using that template. And every dynamic resource instance, as we call it, is created by a template and is being treated by automation like any other kind of, we call it first-class resource, which are defined since ages as static resources in the policy. There's no difference. Below you see here now a picture about what that means. I have like very high level of an SA policy here seen. What you see, and let me start a little bit unusual from the right. What you see are resources. Resources are defined in the policy by, yeah, okay, they have a name, okay, call them AppX server, for example. You define to system automation how to start it, how to stop it, and yeah, how to monitor it, and to what kind of messages to react, messages that indicate an application is being started, messages that indicates it's stopped, message says that an application has a problem, and so on. Those stuff you all define in the policy for a specific application. And we call that a resource. And yeah, and last but not least, you also say where that software should run. So if you have many systems in your IT environment, this application, for example, should run on a host which is called LPAR1. And however, you can now use, after defining those resources, you can group them. For example, I have here created on the right, I have a group called an AppX database. So as the name of group says, okay, there it is a database which later is the persistent storage for that application. However, that group has two members. The members resources are DB2 v9 in both cases, twice. However, what you see a difference is the location. The one time it's running on host LPAR1, or it's running on the system LPAR2. So and actually the application X doesn't care where it's running as long as it is running. Okay. So and here you see also another concept in the policy. It is a relationship. And I made like a very high level description of it. It depends on relationship. That means the application X service requires a database. That's all what it says. So this is the static definition of application X that requires a database in the policy. And that was available, or is available, since many, many years already. So what has been added now, and that's what you see here on the left of that diagram, are templates. Templates are now something, and what you see here, it defines, okay, a template name for sure, it has a template version, but it defines how to start that application belonging to this kind of template, on what kind of messages to listen to. However, there is no real application yet using that template. So the resource name is empty for a template, and also the location. So all that is being defined in the policy. It's being also revised by people and looked at and see approved, that this policy with that template is something we want to activate. And therefore, next change, you activate a policy. Inside the policy, there is a template. And now how do you use that in runtime? So I want to go here to next slide. So again, here you see that schematic policy. So I already explained it before. It defines here 3 resources. 2 of them are in one group, and the last resource has a dependency on that group, and 1 template. So you activate that policy with system automation, and system automation will start to use that information in that policy and start automating those resources. That means it will start them. It will ensure that the applications are running on their locations as defined in the policy. So the result during runtime is that you have a resource, those resources and defined and being observed and yeah, and restarted when they fail, and stopped yeah, when the operator interacts with them. Now there is a time when I'm looking back to the call before, that Mike is gonna create the dynamic resources, and therefore he's using a new command which is called ingdin create from application template. That's the one which is being defined in that policy, and give that new resource the name application for test. Okay, so the result is that you have the resource, and being created here, and you have the app for test, as you see on the most right, running, and giving those kind of and being automated with the same level of service as the other applications as well. So how does it look now with dynamic resources? How would this call now look like? Again, hi Mike, I just received a call, earning the same as before. Yeah, sure, we will do that in 5 minutes. But now he will not, Mike will not create the resources in the policy as a static resource, but he will use a standard template. That template being already approved for this case before and in there. And after 5 minutes later, the IMS revision is done. And what you see here, 5 minutes. So the conclusion is the time it takes to add a new workload is reduced from days to minutes. Okay, so this is some very needed tool to enable DevOps team to work to change environments on request and react on changes to features for applications quite easy. In other words, Eric, Zach, and America can now do what dynamic business demands from them. Last point of that agenda. What means automation in hybrid cloud environments now? So first, let me give a very high level overview about what is hybrid cloud, and especially what is hybrid cloud seen by IBM. So hybrid cloud is actually now a combination of, I would say, 3 different ways of structuring your IT environments. So far, we have talked about traditional virtual servers, which you see on the right. Those IT environments are, kind of static, are running into in a data center and are being automated, as you saw in the last slides. So, but more and more people now starting from virtualization, now coming to also to use the virtual hardware resources when they are needed. People start to, or since long time now already, people go to the cloud by saying, okay, environments are now dynamic and environments are being there on request. And there are different versions of cloud. Either you have a public cloud, that means you don't even see anymore, or you don't own anymore the hardware, the resource behind. You just use the services. That's something in public cloud, and services might be like data storage, but also CPU storage, IT system resources, but to complete software systems like communication systems like Slack, or like and collaboration like an archiving system or developing system for Git and so on and so forth. All that is being available as service in public cloud. Something in between is what we call a private or dedicated cloud. Here, a private cloud means you have the concept of a cloud, but you host it on your own servers, on your traditional servers, and therefore it is a complete private cloud only there for you and your company to work on. A dedicated cloud is now another form where you say, okay, you have those services running, those resources running in public, however, so owned by another company, but there is a contract obligation that those resources are dedicated to your company only. Nobody else can work on them. So altogether is what we call the hybrid cloud. And because altogether those services and servers provide features to be used and to be used together in order to bring out your application, to bring out your product to customers. So in an IBM hybrid cloud world, we as IBM think about that you need to manage your services and you manage your IT systems no matter where they are, no matter if they are running traditional on your systems, traditional in data center, if they are private dedicated cloud resources or even in the public cloud. There is no big difference in the challenges you still have. You have to deploy applications and operate them, to monitor them and to get them started and so on. So you need tools that work with this hybrid cloud setup. So now there's a slide talking about DevOps teams, talking about tools and REST APIs for a hybrid cloud. So a new term is in the slide here. The term is REST API. A REST API is a web service that uses representational state transfer protocols and the given architecture to handle requests on front-end web services. So that's more or less a definition I copied from Wikipedia, actually. REST APIs nowadays are, I would say, omnipresent. And I would call them the glue for almost all integration approaches between tools, all kinds of tools for monitoring, automation, collaboration, and other interactions within hybrid cloud and IT environments. That means within environments that consist either of any combination of traditional data centers, dedicated private clouds, or public clouds. So DevOps teams rely on modern tools and to manage their IT environments. So here you see like a big picture. You see on the left what I bring up already is you see the DevOps teams. You see what kind of tools they are using, and you see a lot of tools. I mean, I could enlarge it here indefinite, I think, but some are there which you might know, like Slack for collaboration, like MS Teams, whatever your company is using. You see Jenkins for especially for the developer to drive the automation of build a new application and to deploy it to some service. You see the symbol for GitHub, where you use as archiving systems for your source code and as a means to share source code amongst people in the development team. You see Grafana as a utility to give some graphic output to monitoring and data, or some kind of a visualization of data being used especially by Zach and Mike, but also seen now by Eric first time maybe, that his application he just developed takes him a lot of resources, and maybe he wants to make it better in the next release. So next release is something where he makes it better, that not so much CPU consumption is being used instead of creating yet another feature, which makes Zach and Mike happy, I would say. However, those are the tools are being used, and those tools are always using and needing an integration with a real environment on the back end, which you see on the right side, the hybrid cloud environment. The hybrid cloud environment is integrated into those tools used by the DevOps teams with help of modern REST APIs. I mean, there is no sense to talk anymore any kind of other integration, but the REST APIs are more or less standard. And this is something now we had needed to also ensure for existing automation solutions, for example, when they want to play a role in that whole universe of new tools, we must be able to develop REST interfaces. So what did we do here? I give now you here an overview about those some available RESTful API servers for automation in a bigger consensus running on these systems. So what we have here is the NETView. In the version 6.3, they developed an API, which then can be used. And now with the SA 4.2, there was an API coming out, which you see here mentioned in the slide, which also makes those kind of REST interface available. And yeah, as you see on the right here, those REST interfaces can be integrated with any kind of web application. Especially we have in mind for integrating it with Zoe, which is the open source version of a new modern interaction with the mainframe. You can either develop Zoe applications or something called a Zoe CLI. And what I will especially talk about in the next slides is integration with Red Hat Ansible. So when you talk, let's see on the left side that there are servers now, open API servers for NETView and for SA. So what we have done in order to make it a little bit better manageable, those servers can run they must not, or they do not need to have to run as separate servers, and therefore also you don't need to manage them as separate servers. They can work as applications hosted by one web sphere Liberty. So it is possible to have that API service running as application within Liberty, which make it much easier to provide those kind of services to web application, to Zoe or to Red Hat Ansible. And that was one thing we wanted to make, that it's quite easy to manage, to have those kind of REST servers. So here I give a very brief overview about what features have been added to NETView 6.3 to have REST APIs here. So for NETView here, you can have like an interaction with the CANS log, which is like the combination of all relevant logs on Z. You can interact with automation table statements where you can have simple automation by creating simple reactions on automation messages coming out, by messages coming out. You can interact with measured network numbers, get task information, and all kind of enterprise information of your systems. So that all has been added in the past in the NETView in the version 6.3. Now let me talk a bit about the System Automation 4.2 and that APA OA 59461, which has been added to create REST APIs here as well. So, and here, first thing what we really ensured is that we are now able to use the REST APIs to work with that new concept of dynamic resources. So you can now use the REST APIs to create and delete them. But more than only interacting with dynamic resource, you can start, stop, suspend, resume all resources in the currently defined in the policy. And for sure, you can also get all details of all resources. So you get static detail information like who's the owner, where's it running, and so on. But also, and that's the concept of REST, it is the hate OAS concept. That means whenever you get resource information being returned via that REST interface, that REST interface is very helpful to give you a link to only those actions which now can be work on those resource objects being returned. So if a resource object tends to be or is currently being offline, for example, you only can start it. And for this, you get a link. Okay, so you don't have to really decide by yourself. So Hate OIS helps you to traverse through the objects being returned by REST APIs and do actions which make sense. Yeah, and there's more to come soon, so that trust me, I'm personally working on that. So we will work on or we keep on adding more and more API features in short periods to that API. So what has been added to the SA REST server is like an embedded API browser, we are making use of something some people of you might know, the Swagger API documentation. Swagger is de facto standard of defining or describing document APIs, and it comes actually when you open your when you open your web browser with a special URL, then you see in the web browser a list like you see here. You see all those endpoints, are they called, like here in templates and resources, and what actions you can do with that. Get is, as the name says, get information. Post is to put some information into the system to create something new, and delete is to remove it again. So, and all those actions are like a standard for REST interfaces and are available here now for the SA API. Swagger, this kind of like representation is more than just a documentation. It is also interactive, able to try those calls from that API itself. From that the browser window itself. So you go on get and say you try it out, and then you for example can try the call out what you would use in your program, but you don't need to write a program. Try it here in the Swagger UI. Now I want to shift a little bit the focus, and so you learned about dynamic resources, you learned about the REST interface, so how it's being used, and I want to talk about Ansible. So if you have not heard yet, Ansible, and here again it's a copy, allows you to automate ZOS applications and IT infrastructure as part of your enterprise automation. So for more details, I put the link there. You can read by yourself. So what it does is Ansible is actually one big standard in the hybrid cloud world, especially on distributed, but now more and more also on these systems, to interact with automational tasks with those environments. Automational tasks can be everything, can be starting from deployment, changing configuration, but also adding new resources like adding new users, adding new disk, creating new directories, creating backup, and so on and so forth. There are literally thousands, if not millions, of different playbooks already available and made available from companies like other hardware companies to interact with their hardware over Ansible. So, and IBM Z is since a couple of years also playing a role in there. So Ansible just give you a very, very high level of some concept. So Ansible has a concept of so-called inventory. So that inventory is something maybe in the past you have, or nowadays you call that CCMDB, a description of everything what you have, the description of all the resources, made a traditional virtualized servers, private dedicated cloud resources, servers, and or public cloud servers and resources. They all need to be part in the inventory. They can be discovered for sure, but they need to part in the inventory that you later can talk with Ansible and tell him to do something on the systems which are in the inventory. So how is Ansible now interacting with those systems? And and traditionally it uses, it does not need any kind of like agent or something like that to be installed on the server. And there's nothing that you need to prepare on your server that Ansible can work with it from remote. Nothing is not quite true. The only thing what needs to be available is you must be able to interact either via SSH or by a REST interface with that service. So that is what Ansible offers you to interact with hybrid cloud infrastructure with help of SSH and REST. Ansible has a concept which is called the playbook concept. A playbook is a description, and it's a description in a kind of like, yeah, more or less in a normal English language. However, it is, yeah, the structure, how it has to be. It's called a YAML file. And inside are tasks. Those are tasks where you describe what to do and what to achieve. Actually, it's not really that you that you need to code something like, if this is there and has a state of this and that, then you do this and that. So there is no if then else to be configured or in the playbook. It is a description. A playbook is a description of what to be. So it is a description of tasks that describe the target, the goal, so to speak, that has to be reached. So for example, as a task in Playbook, you say, make that WebSphere Liberty in version 8.5 is being installed, for example. That's it, okay? And Ansible makes that happen. So they make it happen by checking it, by downloading it from some repository, by pushing it, and by starting it. So this is all configured in one wish in your playbook, for example. And yeah, and we enhance on this concept. And how you will see in the coming slides. But first, who is using now? Yeah, Ansible, it's used by the DevOps team by actually, again, using APIs of Ansible, by talking with Ansible with the REST APIs, but Ansible also has not only one, but many different user interfaces. Choose the one you like. And in there, you see things like inventory and playbooks available. And then you can say, okay, I want to have playbook A, and I want to, the playbook A describes of bring out a new web server with an application, for example. And this playbook, Ansible executed on my system, which is in the inventory being labeled as an application host, for example. And as said, in the inventory, again, you cannot only just list the servers, but you can also group them there. You say, okay, for test systems, I say, okay, following 5 systems are my test systems. So then the DevOps team says, okay, Ansible, please deploy that application XYZ on any test system and tell me when it's done. So that's how Ansible works here. Here is an example how it would work again with our dynamic resources. And in the upper left, actually, what you see here is some not yet available Zoe client, Zoe CLI. If you heard about Zoe, you may be familiar. For now, you just need to understand it is a CLI, okay? That CLI can be hosted on any kind of system. It can be hosted on your laptop. It can be hosted on any Unix system. It can be hosted on USS, Unix System Services System, and so or wherever. It interacts with your system and it interacts through that REST API by listing here the templates which are available. So in that YAML file, in that playbook, what you see here on the left, you define some kind of variables. You say the template name. You say how should be the name of the resource to be there, to be created, where to create it, and so on. And yeah, this goes into the playbook. Ansible will use a playbook, call that APIs, and create those dynamic resource. It will look similar to this. For example, if you don't use an UI, but if you use like the Ansible command interface, you see there's a play to create and resume some SA resource, some task. So first, every Ansible starts by gathering facts. I mean, it does what it says. It first needs to find out, so what's going on there? Is the system there? What is installed there? Is there enough space, and so on? That's what Ansible is doing for you. Then is in this kind, there's a task being also inside the playbook. You don't need to worry about that we really make sure that that template that you specified is existing actually, and the system automation has that policy with that template activated. So it will check, and then it will create the resource of it. So all that is done unattended actually, and what you see here is at the end everything is green. Okay, it's running. One thing what you don't see on that slide here is what you can do. You can simply run that same playbook right after again, and it will work. It will also return with success. It will, but it will return with success. Nothing has changed. Okay, so again, playbook of Ansible describes the to-be state. It describes what you want to have. It does not describe what to do, but it describes the targets. So, and if the target is already there, then Ansible will not do anything. It will simply says, okay, target is already fulfilled. I skip that step, and that's a logic of all playbooks used by Ansible. So I said before that ZOS is now playing a more and more bigger role in that universe of Ansible. So there is something what I want to give you a link here to look at. Ansible shares their playbook as so-called collections on something called an Ansible Galaxy. Okay, so you can go on Ansible Galaxy. That's a concept which has actually introduced already a while ago. And you can share and you can see there and search for content which is available for IBM ZOS. Here is now the one picture about which is from this month, actually showing you the collections for ZOS. So those are ZOS core collection. This is a quite cool collection actually to be used to use Ansible to interact with the job entry subsystem to create data sets, to see contents of data sets, and submit jobs, get jobs back, and so on and so forth. There's a collection especially for ZOSMF and for IMS available. And and again, I say there's more to come in the quite future. So let me recap. So what is the system automation steps on the journey to cloud? What actually I'm doing. So the system automation in the past was an ISPF application. For automation, it has some policy definition that defines the resources to automate on, and it was operated by panels and commands directly issued on the mainframe. In the first supported step of bringing it more into the DevOps world, into the dynamic world of creating resources, we created something which was called dynamic resource. The dynamic resource, that concept is available since SA 4.2. What it means, I tried to explain in the last hour, but that was only the first step. The next step, the new step, is we just added the SA Operations REST API, so that dynamic resources not only are able to be created from a mainframe operator by using NETView commands on the mainframe, but also by using REST APIs, which can be used by all kind of programs, even by using the documentational browser interface, which is the Specker interface. So that REST API is something which makes it easier, especially for DevOps teams and for team members which are not familiar with mainframe, to work with dynamic resource. However, now in the last step, the last slides, I told you this REST API now is a glue to open the integration of the NETView and the system automation, but also you see ZOSMF, ZIMS, and other products. and integrate them with automation tools currently being used in hybrid cloud. You saw one example, only one example by me now today, which is Red Hat Ansible. And I have not mentioned a lot of it, but it's also for very needed to integrate all those products into the Zoe open source environment for modern interaction with mainframe. Okay, with this summary slide, I'm ending my talk for today. So as Anna said in the beginning of this, the presentation, we all look forward to get some session feedback, and I would be happy to get some from you. I say thank you to all of you, and actually I missed now the slide which asks for questions, which I normally add. So for sure, Anna, I don't know if somebody asks any question in the chat, or maybe we can talk and ask questions in the last 5 minutes.
No, there's been no questions in the chat. You and Stuart have said very good presentation. Thank you. I have actually given people the ability to unmute themselves, so if they want to ask a question verbally, they may. But as yet, no actual questions in the chat. Also a reminder to people to donate to this year's GSE charity. That one, NHS Charities Together, do some great work for our NHS in this very difficult year. So you can click on, or there's the money give in the bring your own agenda. As said, feedback, please, not only for the speakers, but it also gives us the information towards next year's GSE, which of course we hope will be face-to-face, but failing that, I think this has been pretty good. Okay, so just leave a pause for anyone that wants to ask a question or to say anything else, and thanks to you all to attending.
Thank you.
Okay, the number of people in the session is now reducing, so I take it that nobody has any questions, and I will end the session now.